Also, to improve the performance of the page replacement, who need the page frame? Who need the free pages? CPU need to access, but CPU process each program, right? So per process, we need certain amount of frame. At that time, we can allocate either one is a fixed allocation. Fixed allocation means each process, no matter what size of the program is, we can allocate the same amount of memory, same number of free pages initial. Okay, 10, 10, 10, 10, 10, 10, or 16, 16, 16, something like that. Also, that's easy, but it's not fair depending on the size of the process, also the priority of the process. So we can consider priority allocation, which means if the process is important or the very big, so we need to allocate more. But problem is, it's very hard to determine what is a priority. Explicitly, we can assign the priority like the CPU scheduler. Also, we can consider the size of the process as the priority. And also, global versus local allocation means local allocation is per process. But sometimes we have the shared pages, as we have seen before, like the system library. So we can consider the global replacement, which means such a global replacement will not use any local, something like that. So we can separate the global and the local pages. I'm going to skip the Numa. Okay. Problem. When you are doing the page replacement, that's called the thrashing. Thrashing means, do you realize sometimes your CPU and your system is very slow? Okay? When you check the CPU, it has the 100. It's almost the CPU is either is 100%, but your system is not working. Almost stop. At that time, when you check the memory, it has a lot of huge number of pages in and out. That status is called thrashing. Thrashing means like your CPU utilization is increasing, but sometimes suddenly it's a drop, but your system is almost stopped, hang, not working because of a lot of pages in and out. Okay, that's called the thrashing. When such a thrashing will be happening? When? We have seen such a case before. I don't want to click all the time, but 1, 2, 3, 4, 1, 2, 3, 4, like some delayed anomaly happen. 1, 2, 3, 4 we use the same number, same pattern of the reference string, but 3 frame, 4 frame case is always the page fault, right? So sometimes that happens. That example is like this one. We have the 4 page frame, like A, main, XB, currently, which means this part is in the page number 2, 1. Let's say this is the page frame number 0, 1, 2, 3, and main is 1, and A is currently 0, X is 2, B is 3, B. What happened? It's 1 through 100,000 times loop. Does it work? You need to bring the I value to the memory. Do you have space? No. So you need to replace. Main we cannot replace. This is a main function. So this one, for example. Then I. X replace I. X, I, X. How many times? A lot of time. At least 1, 2, 3 times of 300 times. Only just one loop. That caused the thrashing. Okay? That's not fair, right? It's a simple, but because of that. CPU cannot do anything because of page in and out. It is doing something, but it doesn't look like doing something because of the bladder. That's called the dressing. How can you address such a problem? I talked briefly before. Why don't we make the group of the pages that works together? That means if we analyze this one, what does it look like? This one. What does it look like? It's a graph. This is the execution time, your CPU time. This is the memory address, like the page number. Okay? So pages, 18, 20. So probably less than 18 belongs to the system. Okay? System pages and the other. And if that one is accessed, then we mark. So which means this one, the page 24 to 28 never been used until this time. Then use. You can see group over there, right? So why don't you make them group? Then it may not cause page fault. That is called the locality in a memory. Okay? Problem? It's not easy to make them group after execution. So we try to find something better. I will explain details later, but I gave you the homework. Do you remember the homework? No? We have a homework. You need to submit it. No? So I asked you to think about the difference between this one and this one. Then right now you can understand why this one is not recommended, right? This one may cause a lot of page fault because the first letter, no, this one may cause a lot of, because J is used here, because when we make the data structure, this is a process, this is a heap, this one has the location of the first one, I. But I is changing. I, 10, 20, then therefore I, J. But if you refer the I first, this is a J and I. So I, this one. It's a lot of 84. Okay? So that is the reason it's not recommended. Okay, so I will complete the rest of the part of the chapter 9 next week. Before we finish the lecture, so why don't you hand out? Why don't you hand out? Oh, no? So this is the quiz. Why don't you try to your best?